Final Exam Study Guide. Question 1. Divide two fractions. When you're dividing two fractions, you flip the second fraction and change the division sign to multiplication. From here, factor. You may have to factor a trinomial, or in this case, just take out a GCF from the first numerator. In the first numerator, there's a 7 in common. So what's left in the parentheses is 2r plus 1 all over r. And bring down the second fraction. Now we can cancel stuff out, namely the 2r plus 1s. And also r can go into r cubed. There will be r squared left. So our final answer is 7r squared. Question 2. Solve the following equation or proportion. This is a proportion. The first step is cross multiply. So when we cross multiply in no particular order, we have 2x minus 3 times x minus 6 equal to 2x plus 3 times x plus 7. Use the FOIL method to multiply both sides. And when you use the FOIL method, on the left side you'll get 2x squared minus 15x plus 18 equal to, on the right hand side, you get 2x squared plus 17x plus 21. Now let's subtract 2x squared from both sides. And actually both pairs of 2x squareds cancel out. So bring down what's left. At this point, it's up to you what side to choose to move the letter. I will subtract actually 15x from both sides. And in the same step, also subtract 21 from both sides. So the 15x's cancel, and also the 21's cancel. So we're left with 2x equal to negative 3. Wait a minute. Let's see. Sorry for the interruption. I need to make a correction. I made a mistake. Right here, this should be negative 15x. And I actually should add 15x to both sides. So that will leave us with 32x on the right side equal to negative 3. Divide both sides by 32. So our final answer is negative 3 over 32. Let's look at the next question. Which of the following could be simplified without first simplifying the individual radical expressions? Well, A is the correct answer because each term has the same like radicals, square root of 12. That's like saying if you have 4 square root of 12s and I give you 5 more square root of 12s, then you have a total of 9 square root of 12s. So A is the correct answer, number 3. Question 4, rationalize the denominator. So we have 2 over 3 square root of 7 plus 2 square root of 5. According to an algebra property, you cannot have an imaginary number or a radical in the denominator. So you have to get rid of those items somehow. For this problem, just multiply the top and the bottom by what's called the conjugate. And the conjugate is a fancy way of saying same terms but use the opposite middle sign. So we'll multiply the top and bottom by 3 square root of 7 minus 2 square root of 5. And multiply the bottom as well by the same conjugate. Now leave the numerator in factored form. And there's a simple way to multiply the denominator times its conjugate without using the entire FOR method. Just multiply your first terms. So 3 square root of 7 times itself. 3 times 3 is 9. And square root of 7 times itself is just 7. So that would be 63. And multiply your last two terms. So 2 square root of 5 times negative 2 square root of 5. So 2 times negative 2 is negative 4. And square root of 5 times negative square root of 5 is just plain old 5. So that gives us negative 20. So 63 minus 20 is 43 for the denominator. Obviously, we cannot simplify this answer anymore, but look out for answers that you may have to simplify on the final exam. Question 5. Solve the radical equation. We have on the left side square root of 26x minus 20 equal to 5 times the square root of x. Step 1, to get rid of the radicals, these are both understood to be square root or root 2. And to get rid of the radicals, you do the opposite of taking the square root. So the opposite of taking the square root is actually squaring. So we'll square both sides of our equation. On the left side, the root and the radical cancel, leaving us with just 26x minus 20. On the right-hand side, the 5 is squared, and that's 25. And the square root of something squared is just that something. Now, just get the x's on one side. Since 25x is already by itself on the right-hand side, let's subtract 26x from both sides. So that gives us negative 20 equal to negative 1x. And the last step, divide both sides by negative 1. With the radicals, you would want to plug in your answer to make sure it satisfies the original equation. Number 6 is very similar in steps as number 4, in which we have to use the conjugate. So question 6, we have negative 10 plus 10i all over 4 plus 2i. Just like radicals, you cannot have imaginary numbers in the denominator, so you have to get rid of them somehow. Again, use conjugate. So we'll multiply both the top and the bottom of our fraction by 4 minus 2i. Now, when you multiply the numerator by the conjugate, this is what you get. You end up with negative 40 minus 20i plus 40i minus 20i squared. And when you multiply the denominator times its conjugate, again, just multiply the first terms to start. So 4 times 4 is 16. And right here, when you multiply the last terms, positive 2i times negative 2i gives you a negative 4i squared. Now, a couple of things we can do to simplify our fraction. Combine your i's in the middle, so that would be 20i. So we have negative 40 minus 20i. And recall, I squared is equal to negative 1. So replace each I squared with negative 1. Now let's simplify a little bit further. So up here, this will become a positive 20i, positive 20 right here. So we have negative 40 minus 20i plus 20 all over essentially 16 plus 4. So that's 20. Now simplifying, combining our integers, we have negative 20 minus 20i all over 20. And we need our final answer in the standard form a plus or minus bi. So we divide each term in our numerator by the 20. So our final answer in standard form is negative 1 minus I. Again, just like radicals, you can't have imaginary parts in your denominator. So you have to use, in this case, you have to use a conjugate. If it's just plain old I down here in the denominator, just multiply the top and the bottom of your fraction by I. All right, our next question. Number 7, use the quadratic formula to solve the equation. We have 5x squared plus 4x minus 2 equal to 0. In order to use the quadratic formula, all of your terms must be on one side of the equal sign equal to 0. Let's identify A, B, and C before we use our formula. A is 5, B is 4, and c is -2. So let's write down our quadratic formula. X equal to -b plus or minus the square root of b squared minus 4ac all over 2 times a. And now let's fill in our a, b, and c. B up here is 4, but it's -4, plus or minus the square root of 4 squared minus 4 times a, or 4 times 5, times c, or -2, and that's all over 2 times 5. Now let's figure out the value inside the radical, also known as the discriminant. So 4 squared is 16. And when you multiply the last three numbers, that gives you a positive 40. So we have 54 under the radical. Now 54, I'm sorry, that should be 56, excuse me. Now 56, we can break it down as 4 times 14, because we know the square root of 4 is 2 on the outside, and the 14 stays on the inside, and that's all over 10. The last step is simplify this fraction. The 4, the 2, and the 10 all can be divided by 2. So 2 can go into 4 2 times. 2 can go into itself 1 time. And 2 can go into 10 5 times. And you can leave your final answer as one fraction. You don't have to break your solution set into two answers. So I would accept -2, or form like -2 plus or minus the square root of 14 all over 5. If my math lab marks your answer wrong on the final exam, please let me know. Okay, question 8 is a word problem. And let me minimize this just a little bit so you can see the entire question. Number 8, a rectangle has a length 2 meters less than twice its width. All right, so let's go ahead and set that up. Whenever you see the phrase less than, you must write your expression in reverse order. So a length 2 meters less than twice its width can be rewritten as 2w minus 2. Now in a separate equation that we'll be using to actually solve this problem, when 6 meters are added to the width, or w plus 6, the resulting figure is a square with an area of 196 square meters. Find the dimensions of the original rectangle. Since we're using, or the resulting figure is a square, then we need to use the area formula for it. So A is equal to S squared. Now let's plug in our given pieces of information. The area is 196, and our only side is w plus 6. Now, to solve a problem like this, you need to use the square root property. The opposite of squaring something is taking the square root of it. So we will take the square root of both sides. On the right-hand side, we're just left with w plus 6. And on the left-hand side, you would normally get two answers, a negative 14 and also a positive 14. So we actually have to test both of them. So one equation is negative 14 equal to w plus 6. And another equation is 14 equal to w plus 6. Now for the first equation, if we add 14 to both sides, then that gives us, I'm sorry, wait a minute. If we subtract 6 from both sides, excuse me, let's try that again. Subtract 6 from both sides, then we get w equal to negative 20. We know that sides cannot be negative, so we can immediately reject this answer. Second equation, if we subtract 6 from both sides again, then we will get w equal to 8 meters. And that is acceptable. Now we need to go back and find the original lengths. So use this equation up here. And where you see a w, plug in 8. So the original length is 14 meters. Again, if you get a negative answer for a geometry problem involving sides, then you reject that negative answer. Number 9, solve the inequality and graph the solution set. First step, see if the trinomial can be factored, which this one can. The factors of 18 that will somehow add to give us negative 9 in the middle are negative 3 and negative 6. Now, we need to figure out, drawing a number line here, we need to figure out what points are going on our number line so we can test the intervals. Well, just do opposite signs right here and here. The opposite of negative 3 is a positive 3. And the opposite of negative 6 is a positive 6. So that splits our number line into 3 intervals that we need to test. Pick a test point, anything less than 3. We can use 0. Pick something between 3 and 6, let's say 4, that's an easy choice. And then pick something greater than 6 to test that interval. Let's use 7. Now you can either plug these test points into your original inequality or your factored version. It does not matter. I'm using the factored version. So let's plug in 3 first. 0, excuse me. So that would be negative 3 times negative 6 and that gives us 18, which is definitely greater than 0. So part of our final answer at the end, later on, is the interval less than 3. Now let's test the interval between 3 and 6 by plugging in 4 for A. So 4 minus 3 is a positive 1. 4 minus 6 is negative 2. Negative 2 is greater than 0. That's false. So we know that the interval between 3 and 6 will not be part of our final answer. And finally, to test the interval greater than 6, we chose 7 as our test point. So we'll plug in 7 everywhere we see an A. 7 minus 3 is 4, and 7 minus 6 is 1. 4 is greater than 0, that's a true statement. So the interval greater than 6 is also part of our final answer. Now, how we write this as a solution set, or an interval notation, excuse me. This interval here, because we have greater than or equal to, and we don't have a fraction, then we use brackets at both 3 and 6. So this left side interval is coming from negative forever, or negative infinity, stopping at 3 brackets. We have to include the other intervals, so to include both intervals, even though they're going different directions, include the U for union. And then right here, this will be bracket 6, and it's going forever in a positive direction, or positive infinity. The graph, the correct answer is C. It matches the graph that we drew. Next question. Graph the parabola, give the vertex, axis of symmetry, domain, and range. This parabola looks like it's in our form x minus h squared plus k. Not quite, but we can rewrite our parabola in that way. H and k is your vertex. So we can rewrite this as x minus 0 squared minus 10. On the final exam, h may not just be 0. You may have something like x plus 3 in the parentheses. In order to find h in that situation, you think opposite signs. But here our vertex is 0, and k is just the number outside, no sign change. So the vertex is 0, negative 10. The axis of symmetry is an equation. It's x equal to whatever h is. And the axis of symmetry is an imaginary dotted vertical line that goes through the vertex and cuts our parabola in two equal parts. So the axis of symmetry for this parabola is x equal to 0. The domain is whatever x can be equal to. You can plug anything you want to for x and get a real number for y. So there are no restrictions for the domain or for the x value. So that's why the domain is all real numbers, or going from negative infinity to positive infinity. Now, in order to get the graph, you pick a point to the left of your vertex. It does not really matter. Let me draw our xy table first. We have 0 and negative 10 already. And that's right here. That's our vertex. And if you plug in, say, negative 1, or if you plug in positive 1, in MyMathLab, all you need are 2 ordered pairs. So if I plug negative 1 in for x, negative 1 squared is positive 1, minus 10 gives us negative 9 for the first y. So that's roughly right here. Now if we plug in 1 for x, that's 1 minus 10, or also negative 9. So here is x equal to 1 and y equal to negative 9. So doing this by hand, you just need 2 additional points. But in MyMathLab, all you need are 2 points. Now, how to find the range? The range is what the y value is. In other words, on your graph, the range is where the y values start. So it starts here at brackets negative 10, and the graph shoots up, up, up towards positive forever. So that's why for the range, that part, positive infinity, is included. Question 11. Solve the following equation. We have 3 to the x power equal to 27. The first step, see if you can get both sides to be the same base. 27, we can rewrite that as 3 to the third power. Now, there's a rule for exponents that states if the bases are the same, then the exponents are the same. So you just set the exponents the same or equal to each other, and you got your final answer, 3. You can check your answer by replacing x with 3. Well, 3 cubed is indeed 27. Question 12. Use the properties of logarithms to rewrite the following expression as a single log. And we have some restrictions there at the end. But let's look here. We have in parentheses log base b of r minus log base b of y plus, outside the parentheses, log base b of n. If you expand logs and you have subtraction, that's the same thing as the quotient rule for just regular exponents. So you can write this as a single log, as a fraction. So this will be log base b of r over y. Something else you can also do is there's an exponent rule for logs. If you have a number in front, then you can make it an exponent. So we can rewrite that last part as log base b of n to the 5th power. Last thing we can do to condense these logs into a single log, because we have plus, that's the product rule, and that means we can write this whole thing as just one product. So we have still a fraction, log base b of r times n to the 5th power all over y. And we have condensed our problem into a single logarithm. Number 13 also involves log, where you're actually solving the given equation. So we have log base 3 parentheses x squared plus 80 equal to positive 4. Now, first step is change from log form to exponential form. So we're currently in logarithmic form, and to change it into exponential form, you have your base, and it's being raised to the number that's by itself on the right-hand side, and that's equal to your function. All right, so using this property, we have 3 to the 4th power equal to x squared plus 80. 3 to the 4th power is 81. Now, to solve this equation, subtract 80 from both sides. So we'll subtract 80 from both sides. And that gives us x squared equal to positive 1. Now, to get rid of the square, the opposite of squaring something is taking the square root of it. So take the square root of both sides. The square root of something squared is just that something, or just x. And the square root of 1 is, remember, you're going to have two answers potentially, a plus and a minus 1. Now, I'll tell you that plus and minus 1 are both correct, but with a logarithmic equation, you have to plug in your answers to see if they satisfy the equation. Next question is an application problem. Suppose that $5,000 is deposited at 4% compounded quarterly. A, how much money will be in the account at the end of 7 years? Assume no withdrawals are made. And how long will it take for the account to grow to $6,000? We have to use our compound interest formula. A equal to P times in parentheses 1 plus r over n raised to the n times t power, where n is the amount of times your investment or amount is compounded in a calendar year. So n is equal to 4, quarterly is 4, t is 7, and r is 4%, but you have to change it to a decimal, 0.04. Oh, and one other thing we're given, the principal is $5,000. So let's plug everything into our formula. We have A equal to 5,000 times, in parentheses, 1 plus 0.04 all over 4. And that's raised to the 4 times 7 power. Do as much as you can in the parentheses before you put everything in your calculator. So 0.04 divided by 4 plus 1, that's equal to 1.01 in the parentheses. And we are raising that to the 28th power. Now you take this amount and times it by the 5,000. And to the nearest 2 decimal places, we get $6,606.45. So that is the amount that will be in the account at the end of 7 years. I'm going to leave our compound interest formula up here to help us answer part B. Part B, how long will it take for the account to grow to $6,000? So everything else is the same. This time around, we're looking for T, that's the unknown amount or value. A is $6,000. Principal is the same, 5,000. And actually the rate and N are still the same. So that was earlier, let's see, 0.04 divided by 4 plus 1. So that is still 1.1, 1.01 in parentheses. N is still 4, compounded quarterly. And T is what we're looking for now. To make this simpler, before we plug all of this into the calculator, let's divide both sides by 5,000. Now 6,000 divided by 5,000, I believe that's 1.2. Yeah, that's 1.2. Those 5,000s cancel, and we're left with, on the other side, 1.01 raised to the 4t power. Now earlier we solved an exponential equation in which we could get the bases to be the same. But here we cannot get the bases to be the same. So if you run into that problem, just take the natural log or ln of both sides. So we'll leave that as natural log or ln of 1.2. Now I'm using the same exponent rule from earlier. Take the 4t and you can move it to the front. So that's 4t times natural log of 1.01. Now we're trying to solve for t or get t by itself. So the next step to get t by itself, just divide both sides by 4 times natural log of 1.01. On the right-hand side, the 4s and ln 1.01s cancel out. And you got t by itself, which is what you wanted. And let's put this carefully in our calculators. So 1.2 ln divided by parentheses. Now with my calculator, I have to enter stuff backwards. Your calculator, you may be able to plug everything in like you see it on the whiteboard. But for me, I have to do 1.01 natural log times 4. I need to close my parentheses and then finally mash equal. So to the tens place, our answer is roughly 4.6 years. So it would take roughly 4.6 years for our account to reach $6,000. To summarize, it'll take 4.6 years, or roughly 5 years, for our account to grow from $5,000 to $6,000. I think the next question is also application. Yeah, number 15. Approximate to the nearest unit revenue for 2017. You're given the function. X is 10. It represents the year 2010. X equal 11 represents 2011, and so on. And S of X is in billions of dollars. So using this pattern, then our X would be 17. So let's plug 17 into our function. So we got 92.482 e to the 0.05185 times 17. And just carefully put that in your calculator. So let's see here. 0.05185 times 17. Then I have to hit base E. And then multiply by 92.482. Let's see. 2012, 17. Continuing with number 15. For some reason, my calculator was giving me the wrong answer, and it was probably me putting it in wrong. So I checked on using the calculator supplied by Google. So I did E, and then the little rooftop is your exponent, and then I typed in the rest of the exponent, 0.05185 times 17. I matched equal, or typed in equal. So that's what the e part is equal to. And then multiply that by 92.482 and rounded to the nearest whole billion, that would be 223 billion. So just be careful when you plug these values in your calculator. Just one wrong misstep will cause your answer to be way off, like it did for me. Question 16 is simply a matter of plugging and chugging. You're given the function a of t. Suppose that the amount of grams of plutonium present in a given sample is determined by the given function a of t, where t is measured in years. Determine the amount present in the sample after the given number of years. So part A, find the amount after 5 years. So in place of t, you just plug in 5. And let me pull up the Google calculator again. E raised to the negative 0.052, times 5. And then multiply that amount by 3. So roughly about 2. I got 2.7, but the answer says 2.31. So let me see what I did wrong here. Hang on just a second. I made a mistake, sorry about that. Instead of 5, I accidentally plugged in 2. So we'll multiply this amount times 3. And now we got the correct answer for A, 2.31 grams. So that's the amount of plutonium present in the sample after 5 years. To solve B and C, all you got to do is, instead of 5, replace T with 30 and get your answer. And then for part C, just replace T with 40, like I did here with 5, to get your answer. Now part D, how you figure that out, find the initial amount of plutonium. Initial amount just simply means that the time hadn't started yet. So in place of T, you just plug in 0. So we have 3 times e to the 0 power. E to the 0 power is 1. So the initial amount of plutonium was exactly 3 grams. Final question, number 17. A sample of 800 grams of an isotope decays to another isotope according to the given function A of t equal to 800 e raised to the negative 0.046 t, where t is the time in years. Part A, how much of the initial sample would be left in the sample after 10 years. All you do is in your initial or original function, everywhere you see a t, plug in 10. So let me pull up the Google calculator and figure this out. So e raised to the negative 0.046 times 10. And then multiplied that times 800. So 505. And we need to round this or carry this out to 2 decimal places. So 505.03 grams of the sample will be left after 10 years. Part B, how long will it take the initial sample to decay to half its original amount? What's half of 800? 400? Yeah. So we're trying to figure out how long will it take for 800 grams to decay to 400 grams. So A of t is actually 400. So we have 400 equal to 800, e raised to the negative exponent given. To make it simpler to figure out, divide both sides by 800. And 400 over 800 is 1/2, or just 0.5. And bring down the right-hand side. Now the next step is to take the natural log of both sides, or ln. So let's bring down the left side, or bring over, I should say. We have natural log of 0.5. And again, you can use that property of the exponent law for natural logs or logs and bring the exponent to the front. So that would be negative 0.046t times natural log of e. Now the reason why it's just going to be negative 0.046t is because natural log of e is equal to 1. So let's bring down what we have currently. Natural log of 0.5 equal to negative 0.046t. And the last step, divide both sides by negative 0.046. So let's put this in our calculator. 0.5 natural log divided by 0.046 negative. And to the hundredths place, this will be roughly 15.07 years. So it will take 15.07 years for our initial sample of 800 grams to decay to exactly half, or 400.